Hello everyone and welcome to another episode of Investigation. In this episode of Investigation, we'll go over 2021 AIME 2 number 7. So in this problem, it says let A, B, C, and D be real numbers such that they satisfy the system of equations. There exists a relatively prime positive integers m and n such that something and find m plus n. So basically, it wants us to find the value of a squared plus b squared plus c squared plus d squared. Now, how do we tackle this kind of problems? Now, if we look at A, B, C, D, that is a complete cycle. When I mean that occurs via this formula or theorem, you might say. In, let's say, x to the fourth plus ax cubed plus bx squared plus cx plus d in such polynomial or such equation, if we set it to 0, then the roots are the product of all roots a, b, c, d is equal to negative 1 to the fourth power, because that's first power, second power, third power, fourth power. So it is positive d. I really should not have used the same variables, but I'll just use d prime. So it's equal to positive d prime. So that is complete. And over here, that is also complete. But how about this? It doesn't have any terms associated with d. We're missing d. And here, we're missing c and d. So we need to tackle this problem either just from the beginning or from the end. Well, from the beginning, we have a and b. And each equation we look at, there is one more variable in it. So we cannot really solve it with the additional information. So we need to start from bottom. And if we factor out some d, let's say is ABC plus BC plus B, or BC plus CA plus AB times D, that is equal to 14. And we're given that this is equal to negative 4. So minus 4D, ABC minus 4D is equal to 14. And now we can use this information, and this information tells us ABC is equal to 30 over D. So 30 over D minus 4D is equal to 14. We can multiply both sides by D. So 30 minus 4D squared is equal to 14D, which gives us 4D squared plus 14D minus 30 is equal to 0. And we can simplify this a little bit more. 7D, that is 2D squared. We can factor this rather easily, actually. Just if you somehow did this step and think, oh, I have to use the quadratic formula. No, you try factoring first. Always try factoring first. And in this case over here, we can factor it as d plus 5 times 2d minus 3 is equal to 0. Unfortunately, it says real numbers A, B, C, D, so we cannot really eliminate any of the roots over here, so we have to discuss with cases. So case 1, D is equal to negative 5. For us to not forget, we just write case 2 as well. D is equal to positive 3 over 2. And in case 1, ABC is equal to negative 6 because ABC times D is equal to 30. And in case 2, ABC is equal to positive 20. ABC is equal to positive 20 because they multiply up to 30 as described in the problem. Now, let's continue doing our this over here. Now, we have used the last two equations. We kind of used this one, but we can utilize it even more with the information a plus b equals negative 3. We can say that we can say that we factor out a plus b because in a plus b we are given this information. This is negative 3 plus AB is equal to negative 4 over here. So AB minus 3C is negative 4, and AB, we can write that as negative 6 over C. Minus 3C is equal to negative 4, multiplying by negative C, because we want to get rid of all of the negatives over here. So multiplying by negative C, we would get positive 6 plus 3C squared plus or equals positive 4C. That is equal to 3C squared minus 4C plus 6. That is equal to 0. Now, let's think about this. Well, delta, or the discriminant, is equal to b squared minus 4ac, 4 times 3 times 6, which is obviously less than 0, so there is no real solutions in this case. So we can go on to the next one. B is equal to 3 halves. So if D is equal to 3 halves, ABC is 20. We can do the same process, yet 20 over C is minus 3C is equal to negative 4. And over here, we multiply, get minus 3C squared equals negative 4C, which we get as 3C squared minus 4C minus 20 is equal to 0 in this case. And let's think about how to factor this. Well, 1, 3 has to have coefficients of 1, 3. How about on the other side? Can we have 2, 10? Yes, we can, because 2, 10, well, we multiply to 4, and the other hand, we multiply to 10. So over here, we need C plus 2, 3C minus 10, that is equal to 0. And again, we still have to consider two cases. One is C equal to negative 2, and 2 is C equal to, 10/3. Now, going back to our original information, we can see that over here, that AB, since A times B times C is 20, we see that over here, in this case, AB is negative 10. In this case, AB is going to be positive 6, I believe. All right. Now, we have one last equation we didn't use, which is A plus B is equal to negative 3. I will move this to the middle because that applies to both of these cases. And well, it's rather easy to solve it now. We can use the reverse of Vieta's formula. We get that it is a root of x squared plus 3x minus 10 is equal to 0. And here we could do 1, 2, and 5. So it's x minus 2, x plus 5 is equal to 0. So A and B are 2 and negative 5, respectively. How about let's try in this case, it is equal to x squared plus 3x plus 6 is equal to 0 in this case, which means that x is equal to, well, there's no x because delta, or the discriminant, is b squared minus 4ac, which is less than 0. There is no real solutions in this case. So we have a equals 2, b equals negative 5, c equals negative 2 in this case, and d we have as this. So d is equal to 3 over 2. Which gives us a squared equals 4, b squared equals 25, c squared equals 4, and d squared equals to 9 over 4. So a squared plus b squared plus c squared plus d squared is equal to 29 plus 4 plus 9 over 4, which is 33, plus 9 over 4, which is 4 in the denominator, and 132 plus 9, which is 141 over 4. The numerator is an odd number, so it cannot be simplified anymore, which means that our answer is 141 plus 4, which just leads to 145. So that will be it for this episode of Investigation, and I'll catch you in the next one. If you have any questions or concerns regarding this problem or not regarding this problem, you can put them in the comments section below. If you have any video ideas, any problems you want me to go over, you can put them below as well. Thank you for watching once again, and goodbye.